Hello everyone, I am Dr. Godindaraman. In this section we are going to discuss with correlation coefficient problem. Look at this problem. The joint probability density function of x and y is given by function of x comma y, x plus y, the range 0 to 1 for x value, y range 0 to 1, 0 otherwise. Obtain the correlation coefficient between x and y. Now see here, when the range is given, limits are given, then the problems are continuous type of problem. Now to find the correlation coefficient, so first of all, to see what is the formula for correlation coefficient. Correlation coefficient R of x comma y, covariance of x comma y, sigma x sigma y. So this is the formula for correlation coefficient. Now covariance is nothing but covariance. So what is the formula for calculating covariance? Expectation of xy minus expectation of x, expectation of y, and then standard deviation the standard deviation is nothing but sigma x square root of variance of x, sigma y square root of variance of y. Now how to calculate variance? V of x, variance of x, x square minus e of x whole square, and variance of y, y square minus e of y whole square. Now to calculate mean, e of x, integral minus infinity to plus infinity x into f of x dx. Then expectation of y, minus infinity to plus infinity y into f of y dy. Then x square, integration minus infinity to plus infinity x square f of x dx. Then y square, integration minus infinity to plus infinity y square f of y dy. Then expectation of xy, double integration of xy f of x comma y dx dy, minus infinity to plus infinity, minus infinity to plus infinity. So these are the mean x, x square, xy. And then marginal function, on x. The main role of marginal function, two-dimensional random variable is given, then convert two-dimensional random variable into single dimensional random variable, the main purpose to calculation of marginal function x. So the marginal function, if you want to calculate f of y, then integration y equal to minus infinity to plus infinity f of x comma y dy. So here dy, then this is a x, f of x. Then marginal function y, marginal function on y, and then f of y to calculate, f of y equal to minus infinity to plus infinity f of x comma y, the derivative with respect to x. So x minus infinity to plus infinity. So now one by one to calculate, because f of x y values only we know that. So first to find marginal function x, marginal function y. So f of x, f of y, f of x equal to the x y range given 0 to 1, f of x comma y x plus y dy. Therefore x plus y, derivative with respect to y. Therefore, when I integrate x constant, then dy integration y plus y dy integration y square by 2, 0 to 1. Upper limit, lower limit. Then substitute upper limit to where y term. This y term only substitute 1. Therefore, x into 1 plus 1 square by 2. This is upper limit. Minus of lower limit, x into 0 plus 0 square by 2. Therefore, x plus 1 by 2. This is a value of f of x. Marginal function x. But don't stop up to this, because of we just find x plus 1 by 2 to write the range of x range, x 0 to 1. So this is our marginal function x. Then marginal function y, f of y to calculate, minus infinity to plus infinity, f of x comma y dx. So 0 to 1 x plus y dx, derivative with respect to x. When I integrate x dx, x square by 2, y constant, dx integration x 0 to 1. As usual, substitute upper limit where in terms of x. So substitute upper limit 1, 1 square by 2 plus y into 1. This is upper limit. Minus of lower limit, 0 square by 2 plus y into 0. The whole terms are lower limit value 0. Therefore, 1 by 2 plus y. The range y range 0 to 1. This is a marginal function y. So the main purpose I mentioned, two-dimensional convert to one-dimensional is marginal function. The main purpose of marginal function, if you want to calculate expectation of x, expectation of y. So x variable mean, y variable mean. So mainly important one-dimensional random variable. Therefore only we are calculating f of x, f of y. Now calculate mean, expectation of x. So expectation of x, how to calculate? Integral minus infinity to plus infinity x f of x dx. Substitute the range 0 to 1 x, f of x value x plus 1 by 2 into dx. So when I multiply inside this x value, x square x by 2 into dx. So when I integrate x square, x cube by 3 plus x integration x square by 2, already 1 2 is there, 4, 0 to 1. So substitute upper limit minus of lower limit, 1 cube by 3, 1 square by 4 upper limit, minus of lower limit 0 plus 0. This is a 1 by 3, 1 by 4. So when I am taking this LCM, 12 is LCM. So 4 cross multiply 4, then 3, 7 by 12. Or write in decimal form. This is a value expectation of x. And then expectation of y, integral minus infinity to plus infinity y f of y dy. Substitute the marginal function y value 0 to 1 y into 1 by 2 plus y into dy. Then multiply y inside the bracket, y by 2 plus y square into dy. So when I integrate y with respect to y square by 2, already 1 2 is there. So 4, y square integration y cube by 3, 0 to 1. So substitute upper limit 1 square by 4 plus 1 cube by 3. This is upper limit. Minus of the lower limit 0 plus 0. Therefore 1 by 4, 1 by 3. When I am taking the LCM, 7 by 12. Expectation of y. So this problem E of x, E of y values are similar. So don't think all values are similar answer when E of x is E of y, E of x is similar value. So don't consider this, because this type of problem same answer. And then x square, expectation of x square, integral minus infinity to plus infinity x square f of x dx, then 0 to 1 x square x plus 1 by 2 into dx. So when I multiply x square, x cube plus x square by 2, already 1 2 is there, so correct, this is x cube x square by 2, 0 to 1 dx. Now to integrate x cube, x power 4 by 4, x square integration x cube by 3, already 1 2 is there, 6. So 0 to 1, substitute upper limit and lower limit. So upper limit 1, minus of lower limit 0. Therefore 1 by 4, 1 by 6. I am taking the LCM 24 and cross multiplication 6 plus 4, 10 by 24, 5 by 12. So this is the x square value. Then expectation of y square, integration minus infinity to plus infinity y square f of y dy, range 0 to 1 y square 1 by 2 plus y into dy. Then multiply inside this bracket value y square by 2 y cube into dy. When I integrate y square, y cube by 3, already over 2 is there, so 6 y power 4 by 4, 0 to 1. Substitute upper limit minus of lower limit, 1 cube by 6, 1 power 4 by 4, this is upper limit, minus of lower limit. Now this is a 1 by 6, 1 by 4. When I am taking LCM, 24 is LCM, therefore 10. This is a 5 by 12, expectation of y square. And then expectation of xy. So xy is nothing but double integration xy f of x comma y dx dy. This is a x range minus infinity to plus infinity, y range minus infinity to plus infinity. So therefore the y range 0 to 1, x range 0 to 1, xy, x plus y dx dy. Now multiply inside this xy value, y 0 to 1, x 0 to 1, x square y plus xy square dx dy. Now first integrate x term, this term first integrate. So y is a constant, x only the variable, therefore now x square is x cube by 3, y constant, x integration x square by 2, y square constant, 0 to 1 into dy. So substitute upper limit 1 in x term, substitute only x term, therefore y 0 to 1 and 1 cube by 3 into y, 1 square by 2 into y square, upper limit minus of lower limit. So therefore y 0 to 1, y by 3 plus y square by 2 into dy. Now integrate with respect to y, y integration y square by 2, so 6, y cube by 3, 6, 0 to 1. So when I substitute upper limit, 1 square by 6, 1 cube by 6, this is the upper limit, minus of lower limit. Therefore 1 by 6, 1 by 6, 2 by 6 and then 1 by 3, expectation of xy. So then variance, to calculate the variance, so variance of x square minus e of x whole square. So when I substitute x square value, so x square value is nothing but 5 by 12, e of x value 7 by 12. Therefore, so this is a 5 by 12, 7 by 12 whole square. This term is 5 by 12, 49 by 144. So when I am taking 144 LCM, 12 into 12, 144. So 12 into 5 to multiply this. So 60 by 144, because the reason multiplied 12 by 12 for this place, minus 49 by 144. So this is 11 by 144 variance of x. And variance of y, expectation of y square minus expectation of y whole square. So same values, 5 by 12 minus 7 by 12 whole square. Therefore 5 by 12 minus 49 by 144, 11 by 144. This is a value variance of y. So this is 11 by 144 variance of y. Now the standard deviation sigma x is nothing but square root of variance of x, 11 by 144 square root. Then sigma y, square root of variance of y, square root of 11 by 144. If you want to convert these values in decimal, to convert and solve, so suppose it's a difficult to taking LCM, so not a issue, just to use calculator and convert every value in terms of decimal to proceed. And then covariance, to calculate covariance of x comma y, expectation of xy minus expectation of x, expectation of y. Then substitute expectation of xy is 1 by 3 minus expectation of x is 7 by 12, 7 by 12. Therefore 1 by 3 minus 49 by 144. When I multiply, so taking LCM 144, then this is a value of 144, 48. So when I multiply 48 in numerator, denominator, it will be converted into 144. So this is the meaning. How to take LCM? This 1 by 3 I want to convert into denominator equal term. So therefore this term is nothing but 3, 1 into 1 by 4, 144 is the value. So now take the LCM. One into 48, 3 into 48. This is the way to take LCM. 49 by 144, 48 by 144 minus 49 by 144. The covariance of x value minus 1 by 144. So now find the correlation coefficient. Correlation coefficient is nothing but R of x comma y, covariance of x comma y, sigma x, sigma y, covariance of x comma y minus 1 by 144 divide by 11 by 144 square root, 11 by 144 square root, then root x into root x, x. Therefore, 1 by 144 divided by 11 by 144. Now to cancel this denominator value, 1 by 144 to cancel, this is a minus 1 by 11. So car of x comma y or suffix x comma y, the value is nothing but minus 1 by 11. So this term should write in terms of decimal is nothing but minus 0.09. I mentioned earlier the correlation, the answer should be a value of minus 1 to 1. Thank you.